So, I heard a rumor. Uh-oh. What's going on? We conjecture ahead.
Although this is going to be weird, and it's going to be about a different.
Title of the conference was something like Ground Truth or Turtles All the Way Down. And so it seems as though there's one Ruliad. I don't think it rules them all. And it might
Yeah,
be
instead
just
it, instead it,
hyper Rulial Turtles All the Way Down.
yes, it's on the back of an infinite number of hyperrural turtles.
Various people are commenting on the outrage of hacking the universe on a MacBook Air.
Hey guys, what's going on? Memes here. So, what the heck am I talking about? So, apparently, I heard a rumor. And shout out goes to Maya Benowitz, who was a guest on the Into the Impossible podcast with Professor Brian Keating. I think she's a PhD, doctor, professor. I don't know yet. All I know is I listened to her on Professor Keating's show, and I'm like, I like this lady. Doctor. I apologize, but hold on. We have the internets. Maya Benowitz. She's a mathematical physicist, ex-hedge fund, quant, AI slash ML developer, agnostic Jew, radical solar punk, and a prospective grad student, future founder, and trees make her happy. I like her. All right, so what the heck are we talking about? Basically, I noticed a tweet. He's like, this is about to get weird beyond belief. I'm like, go on. Context. Very recent cosmology observations with a winky smiley face, so we know it must be juicy. All right, so that got me to go onto the Googles, and I did some Googling. And one of the first things that comes up, actually maybe this was off of Twitter, I apologize for lack of citation, is Webb telescope spots super old massive galaxies that shouldn't exist. Imagine my shock. But oh my god, I'm doing the wrong thing. I'm not even sharing the correct thing. All right, here we go. Welcome to the live internet, everybody. All right, boom. Oh, was it sharing the audio from Ultimate Battle? It's okay. Okay, that was the thing I was just reading. All right, 3 new candidate galaxies, which look like fuzzy red dots, discovered in images collected by NASA's James Webb Space Telescope. One of these galaxies left may have contained as many stars as the modern-day Milky Way, but was 30 times more compact in size. Credits go to NASA, ESA, and CISA. It was brought to us by Colorado.edu today. In a new study, an international team of astrophysicists has discovered several mysterious objects hiding in images from the James Webb Space Telescope. 6 potential galaxies that emerged so early in the universe's history and are so massive they should not be possible under current cosmological theory. Each of the candidate galaxies may have existed at the dawn of the universe, roughly 500 to 700 million years after the Big Bang, or more than 13 billion years ago. That's a long time ago. In a galaxy far, far away. Literally. What is it? They're also gigantic, containing as many stars as... Okay, we did that. Here's the response. Quote, "It's bananas," said Erica Nelson, the co-author of the new research and assistant professor of astrophysics at CU Boulder. You just don't expect the early universe to be able to organize itself that quickly. These galaxies should not have had time to form. Nelson and her colleagues, including first author Ivo Alebe of the Swinburne University of Technology in Australia, published their results February 22nd in the journal Nature. Okay, we're not going to belabor the point. Basically, there's a bunch of links in the doobly-doo. They're all... I haven't read any of these. I may have read the first one's title. And oh, here's some cool pictures. All right. Oh my god, the ads! I feel like we need to review things based on the amount of ads that the pages take up. I digress. Oh, look at that. They seem to be really far away, and we got like some dots and some pixels and everything. I wonder what the data analyst is going to look like. I don't know. Yeah, and there's also from CNET. Oh, look at the artist's renditioning. Well, that's really neat. All right. So, why am I talking about any of this? Well, number one, it's news. Number two, it's up my alley. It's like, wait a second. We've noticed something in cosmological astrophysics that we did not expect, at least according to currently accepted theories. Now, I'm just saying that perhaps our models, we're going based upon the data that we have and everything, and we need to follow the science and the data that helps us develop the science. Now, I'm just saying that maybe there exists a particular model. Maybe some folks have been talking about different things, or perhaps what's old is new again, literally. Oh, what's this? Oh. Full disclosure, this video right here, Eternal Cyclic Cosmology, this is actually fake science. The reason why I say that is the way I was thinking about it at the time. I mean, it did kind of work. You could work. Basically, I talked to Thad, and we had some clarifications, and then we drew on the board and stuff. And this one is even more fantastical, but I think it would explain a lot. Okay. What's that? I just dubbed it Eternal Cyclic Cosmology, basically after Sir Roger Penrose there, Professor Penrose. He won the Nobel Prize in physics a couple of years ago for his work in black holes and stuff. Not actually on. Words are important. Okay. So, I'm just realizing what that may or may not look like. Here's the other thing. Is our Big Bang a localized phenomena? I was streamed 2 months ago. That's pretty cool. Oh, I like the Big Bang Theory. That is a fun show. Okay. So what the heck is this crazy person on the internet saying? I'm just saying that apparently the original definition of prime numbers was defined as a number that's only divisible by itself in 1. We changed that in 1945. Apparently it helped make doing some rig problems or something easier. I don't know. But essentially, why did we take the 1 out? Might that be important? I thought dividing by 1 didn't do anything. I had the conversation with Thad that apparently that might do something. Because apparently within math and maybe even science, maybe not as much as we see it within mathematics, but this little cool thing called the gamma function allows potentially twisting of metrics in very interesting ways. I'm just looking at the model before, and what I'm saying is, what happens if the universe is older than 14 billion years? I think that would explain a lot. I mean, a lot of the quote-unquote dark matter, if we've been around for longer, wouldn't that just mean there'd be more black holes? Do people know? Do we have the data? I don't know. We're getting better and better instruments. We'll be able to find a lot of interesting information. And knowledge is power. So what am I saying? Basically, on the smallest sizes, what are you going to have? You're going to kind of have something like this. Basically at around, that was trippy, man. Whoa, don't click on it too much. All right. So, and yes, I had a video and an iPhone. Oh, that's a really fancy camera. I like shiny things. But, all right, eternal cyclic cosmology, what am I saying? Basically, on a size that would be smaller than this on most folks' devices, and about 10 to the negative 8 meters. So basically, it's essentially the magnitude of the Planck mass in meters, like 10 to the negative 8. You're probably going to see something like this, probably going to be in a small circle or circular there. And that son of a gun, to my knowledge, is essentially spinning like at the speed of light. I'm adding that in, I'm conjecturing. I don't know that. I don't know if the calculation... Think of it kind of like if there's like a blender or something, or some very high precision machine. You've got this little thing, which has a vortex as well, so what happens is, all right, hypothetically, that's essentially the complement of the hyperbolic figure 8 knot. can be projected as like a little 3-sphere or whatever, if in our realm of 3 plus 1 or 4-dimensional hyperbolic reality. Literally, I used that term. I warned that not to call it that. Well, we're not going to decide. History will. But essentially, that thing is whirling, and there's a particular articulation. Let's say from the bottom, you might have things sucked up. Goes up that vortex, it loops around doing an incredibly heavy articulation, and you could have stuff coming out the top end there. The claim is our quote-unquote universe, our realm of persistence, what we know as universe, recycles itself. Because right now I'm saying it's a steady state, at least currently. So basically what I'm saying is, why might we be seeing these galaxies? Let's tie it all around so I actually make some coherent sense. Basically, I totally believe that we rewind general relativity and we go back to, I don't know, like about 14 billion years. That makes sense. Why is the universe expanding? Is it relatively expanding? What happens if all of a sudden you got this crazy thing right here, all of a sudden you might have some supermassive black holes, you might have whatever it might be, any type of matter. It gets sucked into literally the reference point of 1 within our realm of persistence. It gets slurped up, all congealed and crazy stuff and things going on. It's also connected by internal Octonian logic. I'm still learning what that means, but at least when I watch it, it's fascinating. There's a video somewhere. I should probably link it. But, yeah, it gets slurped up there, and let's just say, hypothetically, you might have something, I don't know, I mean, like a quark gluon plasma. It's kind of like a hyper blowtorch at the center of our quote-unquote universe. That's blasting out, essentially, kind of like what we would probably observe as a Big Bang, no? No, just a primeval, quote-unquote, fireball or something like that. I mean, if you get all that stuff coming out, and then you have all this matter and energy, it just starts to come together. Let's just say it's in a superfluid-like structure, something that kind of acts like it, which space is a quote-unquote vacuum. I mean, there's nothing there, but there's energy there, present apparently. Yeah. As I believe Professor Feynman said at one point, a dream from like 20 years ago, after superfluidity, basically, like in the Newtonian experiment, you take a bucket of water, you spin it, what happens? You're going to get a vortex in the center. If you do that with a superfluid, rather than being a vortex at the center, it will basically stand still until there's enough torsion and energy or whatever built up that individual vortices just start filling in it. I mean, if we already know that's the case on the macro scale, might it be possible on the scale cosmic? Now again, I am not a professionally trained cosmologist. It's Professor Brian Keating. I think Miss Benowitz as well. Now, again, I'm just saying that if we already observe it, might it just keep happening again and again? Just kind of like, maybe that's why we had like the old Bohr model of the atom and stuff like that. So why? We see it in our solar system. Why wouldn't that be the case? Now, we were a bit off. It kind of seems more like the galaxy in some ways, but I digress. All right. So what is the claim? The claim is apparently we're seeing observations, which... Did I declare this outright? No, I was probably a coward. I mean, I'm a dude wearing a yellow shirt on the internet, wearing sunglasses and a bandana. Take it for what it's worth. If there's one thing I've learned, it's that crazy people notice things too. So basically, we have these galaxies that, according to our current model, we don't think the universe is old enough for these things to be the case. I mean, doesn't that just immediately raise the question? What if the universe is older than 14 billion years? Is T greater than 14b? I'm going to conjecture it is. It would explain a lot, and seeing as we can only see out about 93 billion years, according to some of the calculations, there's one before. I don't necessarily think I derived the logic right, but the numbers worked out. If our actual quote-unquote universe is about 15 quadrillion light years, about 10 to the 32 meters, that's 6 orders of magnitude greater than our current model, or at least as far as we could see, or at least we could see. Now, I mean, at that point, if all of a sudden we're a bit of a vortex of just an enormous amount of mass being fired out at potentially superluminal speeds, that means faster than light. I'm not exactly sure how that works, but some people have conjectured it. I'm happy with going at about the speed of light, or like 0.999999 times that. I think it would have similar effects. But all of a sudden you're breaking out. All of a sudden you have mattered energy breaking off. Starts to swirl. Those little swirls. It's, what is it? Like vortices. I believe it was Physics Girl. Got a great video on basically smoke rings and just seeing vortexes. And apparently that's like viscosity. It's like eddies generating smaller eddies, breaking off into lower eddies, breaking off into viscosity. I totally butchered that rendition. But all I know is, hey, Kali, neutron decay cosmology. I was going to do a video on something else and basically just start off with neutron decay cosmology. It's about something kind of completely different. I think it's up your alley. We need to talk. But it doesn't necessarily have an end as far as the current model goes, from at least as far as an internal observers to my knowledge, it's eternal. A lot of what you've been saying. So, I mean, I'm a dude on the internet, take it for what it's worth, but I think this would line up at least with the model in that basically think of the center of the universe, or of our realm of persistence per se, as basically a cosmic blender. It's slurping up and it's spewing out, and that's basically going to cycle through as a big bang. But the great part is, if the universe is eternal, which it's looking that way, just I claim, at that point, everything would kind of go back around, kind of get slurped, spit out again. I'm like, wait. If we're going to believe the Schrodinger equation and go into like the many worlds things, I'm like, one of the things I learned from Professor Carroll is, when you're dealing with infinities, that's a long time. So if you're going to say that any possible occurrence could happen, if you have infinity time, I mean, doesn't that mean it's Turing complete? It could literally process everything. It might take a really long time, but given enough time, is like the typewriters, and you got like some monkeys or something. Hey, I'm basically doing that on the internet, except instead of furiously mashing my keyboard, I've done a lot of that. I'm just ranting to you good folks on the internet. But Kali, I hear you. Well, the thing is, it's people know what they know often well. But when confronted with something unfamiliar, we often just go with what the people we know and trust are saying. I mean, isn't that just kind of human nature? I mean, it makes sense to me. I mean, that's usually what I don't always do that. That's probably why I don't get invited places. But that's okay. We have the internet for that. But basically I'm like, okay, I think that wouldn't that essentially explain like why we're seeing very large, gigantic galaxies that shouldn't exist? Because if we're seeing about less than 100 billion light years, and we get like, instead of 10 to the 26 meters, if it happened to, let's say, be about 168,000 times larger, about 10 to the 32 meters, it's very big. And if it's very big, when we see older stuff and things, and I'm not saying that's why this is a particular great attractor. I'm just saying that if we might be able to science our way out of it. Essentially, if humanity could persist for before we get ground up and spit back out again, or stray space rock that just smashes the earth and destroys us, this is where I agree with Dr. Eric Weinstein, in that I feel like we should diversify our planetary portfolio. We should learn from the mistakes of the past and try to do better. Why? Because that's how we level up, I claim. But that's all I got for right now. Again, links in the doobly-doo. Feel free to peruse as you would, but that's all I got for now. Peace out, everybody. Be safe and take care of yourselves. It's a wacky world out there, but I got some hope. See ya.
Have you guys checked out the Memes of Destruction's channel? He's an interesting dude. I like him.